Welcome back. This one says if x to the 3 plus y to the 3 is equal to 5, use implicit differentiation to find the second order derivative of y. So we got to use implicit differentiation. We just talked about that yesterday. So let's do that. So if we go x to the third plus y to the third is equal to 5. And we're going to take the derivative, d dx of that. So we have to take the derivative of each individual term. So that's going to be 3 x to the 2 plus 3 y to the 2. And then the implicit differentiation part comes here, where remember this is really just the chain rule, but we have to go dy dx. And that's how we're going to find our derivative of this, right? And then is equal to the derivative of just 5, any constant, is 0. And now we just solve for dy dx. dy dx is equal to negative 3x over 2 divided by 3y squared. So dy dx is going to be equal to negative x squared over y squared. Okay, so we've done the easy bit there, right? We've done that one. Not too bad. Now what we got to do is differentiate this again. Or find the derivative of this again to find the second order derivative. So if we do that, what we need to do is we've got something over something. So right off the bat, what we need is a quotient rule. So there's our quotient rule. So let's start figuring out what f, g, and g prime and f are. So f in this case, we're going to call the top one. So we'll say f is going to be equal to negative x squared. F prime is going to be equal to negative 2x. G is just the bottom term. That's going to be y squared. And g prime is going to be equal to 2y. Now we just got to plug it into the formula. Oh, actually, I take that back. Because I messed up here. G prime, I said, is just 2y. It's not just 2y, right? And we need this. It's going to be 2y times dy dx. That's important. We need that part of it because later on when we put this in, I know what this is equal to. Dy dx. Remember, it's equal to this. So when we put this back in, it's going to go in as this as well, right? That's going to go in with it. All right, so if I move on down here, we've got, what are we calling it? Yeah, using that notation. So let's say the second order, oh, my pen stopped working. There it goes. Second order derivative, so d2y is the way that's written, dx is going to be equal to, and I'm just filling out the quotient rule now, so f prime goes first, so minus 2x, and then g, so y squared, minus f was negative x squared. And maybe let's put that with a big bracket. So I can do a little bracket like that. G prime was 2y times d sorry. Losing my voice, sorry. Dy dx. And then close the bracket. All over y squared squared. Now remember, I already said that I know what this is. So when I write this in next time, I'm going to write this in instead as negative x squared over y squared, because that's what dy dx is. That's what we found out up here, right? So I'm going to replace dy dx with this term. All right, so let's keep going with this. I'm just going to simplify this again. We've got negative 2xy squared. Negative times a negative, I'm just going to change that to a positive right now instead of this, like, what we have going on up here. So plus 2 x squared y. And then instead of dy dx, I'm going to write negative x squared over y squared. All over 4, or sorry, y to the power of 4. Okay, so now we're going to do some fancy solving here. So right off the bat, this part isn't fancy. Right off the bat, we can simplify the y's here, right? So we got y up top in this term. I'm just going to cancel that now. So we got that cancels with one of those. I'm going to rewrite this again, just so we catch every step here. Negative 2x y squared plus 2x squared, or actually minus, because there's a minus symbol here, so I'm just saying minus now, minus 2 x to the 4th. I've just combined that x and that x, so x to the 4th. And then y, I've got one y in the bottom. I'm going to call that y to the negative 1, all over still y to the 4. Now what I'm going to do is I'm going to factor out what I can on the top here. So what I'm going to be able to factor out here is negative 2x, and now, like, that's obvious, right? That I'm going to take out a negative 2 and I'm going to take out one of the x's. But what's not maybe as obvious is that I'm going to take out this y to the negative 1. That's also going to make it kind of nice and neat. So I'm going to take out y to the negative 1 and then see what we have left. So after we do that, when you take out y to the negative 1, you factor it out of this term. Usually it's like we're dividing out something, right? But in this case, since I factored out y to the negative 1, which is really like 1 over y, it's like instead of having y to the 2, now I'm going to have y to the 3, right? If you took out just a normal y, then you'd take it down 1, right? It was 2, and then you take it down to 1. But since I'm taking out a y to the negative 1, this 2 is going to go up 1. It's going to gain 1. So y to the 3 plus, what do I have left in this term? I only have x to the 3 left in that term. And the reason why I did that, oh, actually let's put this all over y to the 4th. I'll do one more sneaky little move, is y to the negative 1, that can go down, right? That's really saying that y to the negative 1 to the bottom. So I'm going to rewrite this again as negative 2x y to the 3 plus x to the 3 all over, now I have an extra y, so y to the 5. And one thing that might not be quite so obvious, and the reason why I did this whole thing, is y to the 3 plus x to the 3. I know exactly what that is. If I went all the way back up to the top, y to the 3 plus, or sorry, x to the 3 plus y to the 3, that's equal to 5. So I can simplify this quite a lot more by just calling this 5. That's 5. So I'm going to simplify this again, and then say this is negative 2x times 5 over y to the 5, which is equal to negative 10x over y to the 5. And that is my second order derivative. So d2y dx. Alright, so that's all I'm going to say for this video. I think I might make one more for 7 too. Just, it's another tough one that I think would be worth going through. So, yeah, see you guys in class.